the camera off, but I did it.
You did it?
Yep. If you're there, we're going to get started in a minute. I'm just giving people a little bit of time to get on. So sit back, relax, and get ready to do some serious quadratic solving. I'm also doing this from my phone right now, which I don't normally. So just kind of bear with me here while we get this all oriented. To anybody who is just logging on, welcome guys. We're going to go through all of Unit 4 tonight. The big thing that I would tell you is you can either just send me messages on Remind, or you can interact through YouTube through the chat. You just need to be logged into your YouTube account to do that. So it's up to you what you prefer. Whichever you like more is fine by me. Just make sure that you pick one of them and know how you can chat with me throughout this. And we're going to get started in a minute. Oh, well, that's not good. I got to turn those notifications off. Margaret, I'm feeling good. Thank you. Let's see if I can do that really quick. Hold on. I just got this phone. So we are learning together how to do this. Notifications. Guys, where is message notifications? Messages. No for right now. Okay. So, hi guys. Welcome to the Unit 4 live stream. I thought I turned those off, but I might not have. So we may switch to an iPad in a second if we can get this to work. So we're going to go through all of Unit 4 tonight. You guys can either message me on Remind or message me on YouTube right here, okay? So whichever way you would prefer is totally fine by me. Send questions at any point. We're going to go through all of Unit 4, and we're just going to jump right in. So the biggest thing that I heard you guys talking about today was dealing with dealing with discriminants, and dealing with completing the square. So some of this other stuff we're going to talk about, but I'm going to try to hit on the stuff that you guys definitely seem to struggle with the most as we go through. But the first thing that I want to make sure we're comfortable with is factoring, because this is really like Algebra 1 review, right? If we can't do this, then it's going to be hard to do anything else. So the first thing you should always be looking for when you do any sort of factoring is you should be doing looking for a greatest common factor. So there's a lot of these with the GCF. If I look at this and I look at this one. Well, that has a GCF. This one has a GCF, right? This one has a GCF. So a lot of these are things where I would want to look for some kind of greatest common factor first before I actually go through and do any factoring. It's going to make my life easier. So let's say I start on this one. When I'm looking for a GCF, I'm looking for the lowest exponent. So if that's a squared and that's a to the fourth, the lowest exponent of those is a squared. Meaning if there's 2 in one and 4 in the other, the most I can take out of both is 2, right? And then for the b's, I've got 1 and 2. So I'm going to take out a b to the first. Now, what I'm going to really be doing is dividing, but I can also ask myself, okay, what would I need to multiply by to get this back? So if I already have a squared b, I would just need to multiply by 1 to get a squared b again. Plus, if I already have a squared b, well, I would need another 2a's, and I would need another 1b to actually get that back. So that's the thought process that I'm going through with a greatest common factor, okay? The next one, so 3x cubed plus 4x squared minus 7x. Anytime you've got something that looks kind of like this, the first thing I would say is, all right, is there something I can take out? Because this doesn't look like one of the forms that I'm used to using. So I'm going to take out an x, and then I would have 3x squared, maybe, plus 4x minus, sorry guys, I'm not used to doing this on my phone, minus 7. So I'm taking those out, right? Now, what's left over is a trinomial, and this I can factor by grouping. So I've still got that x, and that shouldn't go away. That x should still be hanging out there. It's still part of my final answer. But this is going to be 3x squared, and the minus 7. Remember, split the middle. Those don't change. And then we're going to do a times c. So I'm doing 3 times negative 7. That's negative 21. And the things that add to be 4 but multiply to be negative 21 would be 7x and 3x. So then I can take out the GCF of each part. And what I wind up with there is 3x plus 7 and x minus 1. And if that's something you need to go through the actual grouping part, send me a chat. We can go through one. But generally, that's something you guys have been doing great on, so I'm not going to spend a ton of time on it. One like this one, not very difficult. I'm just saying what adds to the middle multiplies to be the end because my leading coefficient is 1, right? And so that would be x plus 4 and x plus 1. Remember that you can always put in your calculator the number you want them to multiply to over x. So you can always put that in your y equals, and that will give you all the factors. So look for integer pairs there. All right, let's do maybe 1 or 2 more. So let's look at this one. I see a cube, and I see that there's no GCF. So the biggest thing I would do here is I would say, let me try to deal, right? So that is a difference of cubes. So this is really x cubed minus 4 cubed. I'm figuring out the cubed root of each part. So this would be x and 4. And then in your other parentheses, you've got x squared, 4x, and 16, because that's 4 squared. Now for your signs, remember you're doing same, opposite, always positive, right? This part will never be any further factorable over the real numbers, so, or at least over the rational numbers, and then you will have x minus 4 left there. All right, last one of these. So here I've got 2x squared minus 50. I'm going to take out a 2 because I see a GCF there. I'm going to take out the 2 from the 50 as well, and that leaves me with 2x minus 5x plus 5. Remember, this is a difference of perfect squares, so you want to have x squared on each of those parts. Okay, so for the most part, these are the exact same things. If there's some particular type of factoring you have questions about, send it to me, but generally factoring has been something we've been pretty strong on, and we're going to use it when we solve by factoring next, okay? So the big idea with solving by factoring, and this is something a couple people asked about, was the idea that if you have 2 terms that multiply to be 0, or any 2 factors that multiply to be 0, then at least one of them has to be 0. So anytime I have things that multiply to be 0, I can take each of them and set them equal to 0. Now there can be more than 2, right? There can be as many as we need there, but at least those 2 we're going to have to deal with. So on this one I would have k equals 7, In this one, I would have k equals -2. So I'm getting out two solutions. Notice it's a quadratic, and we're going from there. So let's say I have this one. The big important thing on factoring is that this side always needs to equal 0, okay? So when I factor this, I need numbers here that add to be the middle, multiply to be the end. So that would be, let's see, 8 times 4 is 32. So if I had p plus 8, p minus 4, and I know that has to be positive because the 8 has to be positive because they need to add to be positive 4. And then I'm setting each of those equal to 0 separately because remember, if together they multiply to be 0, each one has to be 0. So I would get p equals -8 and p equals +4. Again, two solutions. All right, let's go a little further. Let's look at this one right here, 4x squared equals 8x. So if it says to solve any way you want, you could move the 8x to the other side, do completing the square, or do quadratic formula. But if it says solve by factoring, you have to be very specific here. So I need to first make this equal 0. So 4x squared minus 8x equals 0. And then this is not a trinomial, but the first thing you should always be looking for is your GCF. So this has a GCF of 4x, and that would leave me with x minus 2. So this would give me 4x equals 0, which would tell me x equals 0, and x equals 2. So that can be confusing for some people because that 4x term, they're not quite sure what to do with. But again, once you factor, you're just taking each term and setting it equal to 0. So you're just going from there. All right, continue to send questions as you have them, guys. We're going to do another 1 or 2 factoring ones. All right, let's look at this last one because this looks like a doozy. So the issue I see here is that this does not equal 0, right? That's my biggest concern on this is that this does not equal 0. So I'm going to make it equal 0. And typically I want my leading coefficient to stay positive. So what I'm going to do is I'm going to move all of these terms to the other side so that my leading coefficient stays positive because the 7x squared is bigger than the 3x squared minus 4x minus 5. Okay, so that's what I'm looking for. So when I do that, I'm going to get 4x squared because I'm subtracting 3 from 7. 4x minus 4x is 0. And then negative 14 plus 5 would be 9. So minus 9 equals 0. And now there's no GCF, but this is a difference of squares. So this is going to be 2x and 3, 2x and 3. It still equals 0, right? With a difference of squares, you have a minus in one and a plus in the other. And then I'm setting each of these equal to 0. So this would give me x equals 3 over 2. This would give me x equals -3 over 2. And that's it. That's my solutions. So remember with factoring, the key is make sure that it's set equal to 0 and then factor away to your heart's content on the other side. Always looking for a GCF first. All right, if there are any questions about factoring, we're going to take a second, send them if you have them, anything that I can answer about factoring. And if not, we're going to start talking about I's. And I know you can't see me, but that weird sound was my water bottle. Okay, I'm going to start talking about I, and if we have other questions, we will come back to them, okay? But please make sure to just send them along. So first thing I'm going to talk about with I is just regular old simplifying radicals. Let's think about that. So if I have -84 plus square root of -84 plus square root of 36. So the first thing I would start with is the one that I absolutely know. Julie, let's go back to that. Why does the 4x equal 0? Okay, so we'll come back to that one we were just talking about. So Julie asked about this one. So there, that term, we'd have 4x equals to 0, right? And you could divide both sides by 4, so you just wind up with x equals 0. So basically what you're doing is setting that equal to 0, and the only time 4x will equal 0 is when x equals 0. Hopefully that makes sense. Okay, so for these radicals, let's think about simplifying these. Square root of 36, I know that's a perfect square, that's just 6. And if you didn't know that, you could put it into your calculator. As long as you got an integer out, you'd be fine, okay? Now, 84, let's think about what I would do with that. So first of all, I know that's not a perfect square. So that's my start. Now, I do know that this is the square root of -1 times the square root of 84. So already, I can separate that into one radical that's going to give me an imaginary number and one that's just going to give me an irrational number. So that helps me a little bit. So square root of -1 is just I. Square root of 84, okay, well, 84 is 4 times 21. So this would be radical 4 times radical, sorry guys, 21. So square root of 21, there's no other perfect squares within that. So this is, square root of 4 is 2i, radical 21 plus 6. And you can't combine those at all. That's as combined as that gets. Okay, so with i's, really just bring that negative out to the front and you'll be fine. All right, next one, let's do some multiplication. So I've got 3i times 4i times -i. Remember that i's are going to work a lot like regular variables would, right? So if it was an x. So imagine this was 3x times 4x times -9x. I know that I would multiply the variables together. So this would give me I to the third, right? And then 3 times 4 times -9. Well, 3 times 4 is 12. Times -9 would be negative, let's see. Sorry, I'm trying to do this in my head. So 12 times 10 would be 120, so negative 111. I'm sorry, 108. I'm good. And then from there, we can simplify. So I cubed, that is really just equal to -I, because remember that that's I squared times I to the first. I squared is -1. But remember, you could also put I cubed in your calculator and check yourself. So that negative and that negative would become positive, and so that would just give me that. Okay, next one. Thanks, Margaret. Glad that we got that update. All right, next one, looking at these. So -3 times 1 plus 2i plus 2i times 3 minus 4i. So treat these just like variables. I'm going to distribute this out. So -3 minus 6i. I'm going to distribute this out. So plus 6i minus 8i squared. And generally, I can just combine like terms. The -6i and the positive 6i cancel each other out. But here I've got -8 times I squared. And remember that I squared is -1, right? So this is really -3 plus 8. And so this would really just simplify down to be 5. All right, next one, let's do one of these. So 3 plus 5i quantity squared plus 6 minus 2i quantity squared. So 3 plus 5i squared, remember what squaring means. It means to multiply by itself, right? So that would be 9 plus 15i plus 15i plus 25i squared. And now this is going to be 9. This is going to be minus 25 because I squared is -1, right? So that is going to be -16. And then 15 plus 15i is 30i, right? 15i plus 15i. Now, for this next one, it's going to be the same kind of thing. 6 minus 2i times 6 minus 2i. So that's 36 minus 12i minus 12i plus 4i squared. Okay, we're going to write it on the next line. This baby doesn't want to scroll. Sorry. I'm never doing this on my phone again, guys. So that's 36, and that would be minus 4, because that's an I squared, right? So that's 32. and negative 12 and negative 12 is negative 24i. So now I can combine these because I'm adding here. So this would be negative 16 plus 32, which is 16. And then negative 30i minus 24, or positive 30i minus 24i, which is 6i. And that would be as far down as that goes. Now, if you have a question as we're doing this, please continue to send it, okay? All right, so let's look at this one. I to the 35th. So I'm going to take the 35. I'm going to divide it by 4 because remember, I is a cycle. And we're looking at how many times it would go around a full cycle of 4. And so this would go into that 8 times with 3/4 left over. In other words, my remainder is 3, which means that I to the 35th is equivalent to I to the 3rd, and I to the 3rd is negative I. And you can always check that in your calculator, right? All right, let's go to 7. So I to the 44th x plus 3x. So let's take a look at this. So I to the 44th, let's start there. Because right now, it doesn't look like there's much I can combine. So I to the 44th, to simplify that, I'm going to do 44 and divide it by 4 because I want to see how many times it would go through that full cycle of 4, right? So from there, I see that that is 11 remainder 0. And that's really the key because that means this is equivalent to I to the 0. And any number that we can think of other than 0 to the 0 is 1. So I to the 44th is equivalent to 1. So this would just be 1x plus 3x. So that's a pretty fancy way to just say 4x. All right, one more of these with I, and then we're going to move on. So x times I plus 1 squared. Let's think about our order of operations here, first of all. So most of you guys, not most, but some of you guys are going to want to distribute this x in. And I caution you against that because remember that distributing is multiplication. And multiplication in PEMDAS needs to come after exponents, right? So this is going to be, let's ignore this for a second. Let's just evaluate this exponent. So I plus 1 times I plus 1. That's going to give me I squared plus I plus 1. And combining those, this is negative 1, that's positive 1. So this is just 2i. Now I'm still multiplying by x, so I'm still multiplying that by x. So this would be multiplied by x. And that is just 2ix. There's no more simplifying I can do there. So don't let an x throw you off. Just simplify the i's down as much as you can and then combine. All right, questions about I. Question about anything to do with I. Any other things I can simplify for you. Any questions from the review packet that were really throwing you off. Please just send them my way. So, Margaret, you guys can see that. Are we supposed to have the whole review packet done tomorrow? I gave you guys the key. I'm really not worried if it's done. I care that you have done enough to make sure you're comfortable for the test. So, I'm not going to collect it and grade it. It's for you, right? You're in an upper level math class. So, at this point, any reviewing that you guys do is for you. So, just make sure you do enough to understand it because I know that was a long packet. Okay, so let's go on. So this is the quadratic formula, right? And the reason that we're going to talk about this is because I want to talk about the discriminant. So people get confused about this because they think it's more complicated than it is. The discriminant is just this part under the radical, okay? And that part under the radical is really important because let's say that I get a problem and I have negative 2 plus or minus the square root of something all over 3, right? So I'm going to give you 4 different scenarios here. So same setup, right? Negative 2 plus or minus square root of whatever over 3. Negative 2 plus or minus square root of whatever over 3. So let's look at these 4 different scenarios, okay? First of all, let's say that that value under the radical, that discriminant, comes out to be 0. Think about what that thing would simplify to. If that came out to be 0, I'm just going to slide that one over a little bit. If that came out to be 0, what you would have is you would have negative 2 plus or minus nothing, which is just negative 2, over 3. So guess what that tells me? For this, I only get one solution because plus or minus 0 doesn't change anything, right? So plus or minus 0 means you plus and minus nothing, the same thing, right? So that just gives me one solution. And it happens to be a rational number because it's a ratio. That's all a rational number is. Now, let's say that this next situation happens. And now I'm going to move these down because I wrote them too close because my phone is not that big. Okay, so let's look at this next one. So for this one, let's say it's 25, right? So I've got plus or minus a number. It's not just 0. But now my discriminant comes out to be 25. Well, here's the thing. I know the square root of 25. This is negative 2 plus or minus 5 over 3. And guess what? That's going to give me two solutions because I'm going to have negative 2 plus 5 and I'm going to have negative 2 minus 5. So my two solutions would be negative 2 plus 5 is 3. So 3 over 3 is 1. Negative 2 minus 5 is negative 7 over 3. So notice here I'm getting two solutions because it's not 0 under the radical, but they're rational numbers, right? They're just nice fractions because I knew the perfect square, right? So both of these types are factorable. If you get a rational answer out, it is factorable, okay? Now, here's the other two scenarios. Let's say that I get something like 11. Do you know the square root of 11? No, we do not. This is an irrational number. The square root of 11 is irrational. And that's because 11 is not a perfect square. So because the number under my radical is not a perfect square, I'm still going to get two solutions because I'm not adding 0. But they're going to be irrational because I don't know the perfect square, right? Unlike when this was 25, I knew the perfect square. And then the last is like, let's say I get this. Now, I don't care if this even is a perfect square. Let's say that this was the square root of negative 9. So I know the square root of 9. Here's the problem. This radical is going to come out to be 3i. And so I'm going to get two solutions again because it's not 0 that I'm adding and subtracting, but they are going to be imaginary. So that's really what we're talking about with the discriminant. Now, if you ever doubted yourself, just find the solutions, first of all, see how many there are, and then go from there, right? So you don't need to necessarily memorize this. Just think through it with logic. So let's do a couple. We're not going to do a ton, but let's do a couple of these. So let's start with this one up here. So negative 2x squared minus 8x minus 14 equals negative 6. So first of all, it needs to be set equal to 0. So adding 6 over to the other side, that's going to be minus 8. And now let's find our discriminant. So b squared, and again, that's the part under the radical, minus 4 times a times c. Okay, so this would be 64, right? 8 squared, minus, now 4 times negative 2 is negative 8. Negative 8 times negative 8 is positive 64. So this comes out to be 0. And you guys can just put that in your calculator. I am trying to show you my work, but you can just throw it in your calculator. So think about what that means. If you have a perfect square, if you have a quadratic formula where you have 0 under the radical, you are adding and subtracting 0, right? So what that means is there will only be one solution because you're adding and subtracting 0, right? And that one solution will be a rational number because there will be no non-perfect square under the radical. If you send it, because this is one of, I would say, the two things that I got the most questions about when I sent out that survey today. Okay, so please send it if you have questions. All right, let's try another one. Let's do this one. So negative 2x squared minus x minus 1. So it's already set equal to 0. So b squared, remember b is just a number, not the x, minus 4 times a times c. So that's the part under the radical. So this would be 1 minus, and then 4 times negative 2 times negative 1 is 8, positive 8. Excuse me. So this equals negative 7. Now think about that. If you had negative 7 under your radical, that is going to give you an imaginary solution, right? I will have two solutions because I am adding and subtracting something, but they will be complex or imaginary because the number under the radical is negative. All right, last one. 5b squared plus b minus 2. So b squared, which is 1, minus 4ac. So that's what's under my radical. So that's 1 minus negative 40, which is really plus. So that's 41. So think about that. Not imaginary, because the number under my radical is positive. So this would have two solutions because I'm adding and subtracting something. I don't know the square root of 41, so that means these would be irrational. Okay, I'm going to move on from discriminant. We'll talk about it a little bit more when we do quadratic formula. But again, if you have questions, send them. Mr. G is yelling, send it from the next room. All right, so let's do some completing the square, and then we'll finish with quadratic formula. Actually, let's do quadratic formula first because that ties into discriminant with what we were just doing. So quadratic formula, you do not need to have memorized. It is on your formula sheet, so thank you, New York State. And you just need to be able to use it. So let's start with this one up top. So looking at this, it's already set equal to 0, so I'm okay there. A is 1, B is negative 4, and C is positive 4. So x equals negative b plus or minus the square root of b squared. Please make sure that's in parentheses. Minus 4 times a times c all over 2a. So now let's actually start by looking at the discriminant here. So this thing under the radical. So that's 16 minus 16. So your discriminant there is 0. So this would come out to be 4 plus or minus 0 over 2. And notice, 4 plus 0 is 4. 4 minus 0 is 4. Guess what? This only has one solution because the discriminant is 0, and it's just 2. So x equals 2 is your solution. So that's one solution, and it's a rational number. Now, because of that, I also know this would have been factorable. So if they didn't tell me what way to solve it, factoring would have been really fast here. All right, let's do another one. So this one equals 0 already. So x equals negative b, so positive 1, plus or minus the square root of b squared minus 4ac all over 2a. So let's look at that. So I've got 1 plus or minus something over 8. And now I'm going to simplify my discriminant. So that is 1 minus 12 times 4, which is 48. So square root of negative 47. Now I look at that. Look at the discriminant. It's negative, right? So because that's negative, this has two solutions because we've got the plus or minus. But they are imaginary solutions, right? Because you've got a negative under your radical. Now 47 is prime, so I can't simplify that much. But I can take out the I. And this would be my two solutions. You could break that up into two solutions. I just don't have the space because I'm on my phone. All right, let's do another one. Let's see. How about one that doesn't equal 0? Let's look at this last one. So 3a squared equals 6a minus 3. So first thing you need to do is set this equal to 0. So minus 6a plus 3 equals 0. Now, I know that there's a GCF in there, and you can factor it out and then do quadratic formula, but you have a calculator, like, save yourself the work. You don't need to do that. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this would give me 6 plus or minus the square root of, let's see, that's 36 minus 36, which is 0, all over 6. So notice you're adding and subtracting 0, one solution, right? So this is just 6 over 6, which is 1. So that's what we're looking at with quadratic formula. And you guys were killing it at this in class, so I'm not going to spend a ton of time. If you want me to simplify a couple radicals, because we didn't do a ton of that in this, feel free to ask. But again, that was something in class you guys were doing really well on. So I'm not going to spend a ton of time on it unless you guys specifically ask. Okay, last thing, and then we'll just leave it open for questions. Let's complete the square. So here's the nice thing about this, guys. You are always doing the same thing, right? Every completing the square question, you're doing the same thing. So first thing you're going to do on any completing the square question, and first of all, this works best if that number b is even, because then you're 2 and you get a whole number and it just makes your life easier. So first thing I'm going to do is I'm going to move my constant to the other side. And that is going to give me a squared plus 14a equals 51. And I leave a blank there so that I have some space, right? So half of this is 7. Square that number, it's 49. And in an equation, whatever you do to one side, you do to the other, right? Now, I'm pretty excited about those numbers over on the right side because that's going to give me 100, which I know the square root of. And from there, I can factor the left side. Remember, it's always this variable and that number. So x plus 7 squared. So here's what I'm getting. X plus 7 squared equals 100. Square root both sides. So x plus 7 equals plus or minus square root of 100 is 10. So x equals negative 7 plus or minus 10, which is negative 7 plus 10 is 3. Negative 7 minus 10 is negative 17. So that was actually probably a lot faster than me trying to factor that. Okay, let's do another one. Let's do this one. V squared plus 6v minus 59 equals 0. So first thing, again, move your constant. And now I'm going to take half of your b term, square it, add here. Whatever you do to one side, you also do to the other. And this is going to give me v plus 3 squared. And this is going to give me 68. Now, I can take the square root of both sides. So that's v plus 3 equals plus or minus square root of 68. Now, let's see if we can simplify this at all. 68, what goes into that? Let's think about it. So 68 is 2 times 34. So let's see if 4 goes into 68. That's 4 times 17. That would be good. So this is square root of 4, square root of 17. So 2 radical 17. So I get x plus 3 equals plus or minus 2 radical 17. So x equals negative 3 plus or minus 2 radical 17. And this actually eliminates you having to do a bunch of other work with quadratic formula and simplifying. So if that middle term is even, normally this is a pretty good way to go. All right, so I'm going to leave it there, guys. That is most of what I'm worried about for your test tomorrow. If you can do this stuff, you know, Buzz and Woody are very proud of you. It's great. You should be fine. So I'm going to hang out for about 5 more minutes. If you have questions, send them my way. And I just want to show you this because I know this is impressive. Oh, won't let me show you. Mr. G went out and bought like the world's biggest microphone. So I feel like I'm on an old time radio show. So next time I'll show you that because I'll have the camera on because I will not have been sick. All right, I'm going to hang out for like 5 minutes, guys. This is your moment. Don't be afraid to be the one that asks, by the way. Other people are hanging out just waiting to see if someone asks a question they have. I can simplify some more radicals. I can talk some more discriminants. I can draw a giraffe. Julie, there can be completing the squares with I. So let's do one of those. So I'm going to scroll all the way down to the bottom to get some space. And that is an awesome question. So let's do one. So let's say I give you x squared plus 2x plus 10. Right? So equals 0. So you could do quadratic formula. This is not factorable, but you could definitely do quadratic formula on this. But completing the square is pretty easy here because that middle term's even, right? So let's do it. So x squared plus 2x, move over your 10, and that's going to be negative. And that's normally a giveaway that something might come out to be imaginary because that negative on the right side might bother us. So half of this is 1. Square that, it's 1. So I'm going to add 1 here and add 1 there. So this is going to give me x plus 1 squared. And this side's going to give me negative 9. Now it's the same process. Square root both sides. So x plus 1 equals, now 9 is the square root of negative 1 times the square root of 9. That's I, and that's 3, right? Whoops. So this is plus or minus 3i. So x here would be negative 1 plus or minus 3i. But again, not anything crazy. If you can simplify radicals, you can do all this other stuff. All right, what else, guys? That was a great question. Thank you for asking. Anybody? Anybody? You got 1 more minute. And then I have to go watch The Bachelor. Important things that we worry about. Mr. G, are you watching The Bachelor? I think he is. Hold on, I have to go listen. Are you watching The Bachelor? Oh, yeah, it's not even 8 o'clock. You're right. All right, guys. Nobody else has any questions. Feel free to still send them to me on Remind. I'll be up for a while. And come in early tomorrow if you want whatever you guys need. And I'll see you tomorrow. You're going to do great on the test. Don't stress. See ya. Bye.